Okay, so now we'll start to investigate the examples in topic 7, okay, decision trees and ensemble methods. So in section 7.1, we have example 7.1.1, which is the providing the example which is used throughout many later examples in for calculation, okay, which is this table, okay, the playing tennis example. So as mentioned in the previous video, okay, so using ID tree it's possible to generate this diagram, okay, the diagram here. This is generated from ID tree. Okay, you will see something similar in your tutorial 5 question 3. Okay, so how do we actually construct this thing? Okay, it's based on the concept of reducing variability and increase purity. And what do we mean by increasing purity? Okay, increasing purity is using some kind of measures so that whenever the note is actually purer, we will try not to split it. Okay, so this is what we mean, okay, by based on the purity. So how do we actually measure it? Okay, the measurement, because we these kind of things involve splitting, so measurement involves use of so-called information theory. Okay, the most fundamental thing in information theory is entropy. Okay, so the keyword entropy, and HS is the standard notation for entropy. Okay, it is a concept which comes from physics. Okay, so the formula for splitting is okay, given by something like this. Pi is the probability of seeing type I, okay, inside a particular split. Okay, and then you need to multiply it with the log of 2, okay, of the thing, okay, because this is in information theory, we are mostly assuming the data are binary. Okay, so that's why we have log 2 there. Okay, and you just sum up because how many classes are there, okay, you just sum them up. Okay, so in Python it's rather easy to implement it. So entropy, okay, you just okay, this thing I should probably call it splitting, okay, something like that. Okay, so NumPy has something called unique, which helps you just categorize. In R is called table, right? Okay, so and then you find the P by dividing over the total, right? Okay, and then you just sum them up. Okay, don't forget there is a negative sign. Okay, because entropy should always be positive, right? The negative sign is to turn it from after the calculation it will be negative value and turn it into a positive value. And what is information gain? Information gain is okay, is for a split. Okay, when we want to split a table, okay, we can choose the certain attribute to actually we follow it to perform the splitting. Okay, so before splitting and after splitting, for each of them we can find the entropy. So information gain is actually before splitting, we should be having something like higher entropy, right? Okay, after splitting, no, actually it should be lower. More organized or not? Okay, it's has something to do with is it more organized or not? So apparently we will be subtracting after the splitting. So after splitting is more organized. So before splitting is less organized. Okay, so that's why we will have some kind of information gain from that. Okay, the implementation is not difficult. You can think of it as just use a formula and just sum them up together. How to understand the formula? The best way, of course, is just to perform some calculation yourself. Okay, so we'll consider. Okay, now we'll try to answer example 7.2.1. Actually, I have already given you an answer. Hopefully, you are able to work it out yourself. Okay, I will try to show you the answer for this. Okay, example 7.2.1, right? So I actually listed out the data here again. Okay, it consists of day, outlook, temperature, humidity, wind, and finally the target or output is play, right? Whether to play tennis or not to play tennis. So the day they are just row index, so this is something like staff ID. Okay, no need to be considered. Okay, so the answer which was not given is for play under humidity or wind. Okay, we have wind or not? Oh well, okay. So it's the humidity. Yes, the humidity. So as mentioned, right? Okay, the calculation of wind is already given over here. So over here, I'm not going to repeat it again. So just okay, the solution for the blank part here actually starts here. Apparently, the notes in the notes, this thing is small because I did not include this table here. Okay, the calculations are not complicated. Okay, now let's begin. How do we actually find all these numbers here? Okay, the reason why I put a TBL here is to indicate a table. Okay, a table where we are considering the playing. Okay, maybe I should start back from this thing. Okay, the play, and under the play, okay, we want to take a look at the wind to see. Oh no, wind. So the humidity. Okay, so this part, humidity. What is the information that will be gained if we perform a splitting? Okay, so how to split? Okay, the way to split is we need to extract these two information out. That's what I've done in your solution. So I just extract two columns, and then I reorganize. Okay, because we want to find the information gain, right? Okay, so we have to reorganize, okay, based on the categories of humidity. So humidity has only two values, right? Either high or normal, no other values. Okay, so that's why I split it into two parts, high and normal. Of course, the index would change as well, right? Okay. So what is this value here? It's the value of whether to yes to play or no to play. Okay, so for humidity equals to high, right? Okay, so we find that there are 4 no. Okay, no, if we represent it as negative, then there are 4 negative, right? There are 3 yes, so if we denote it as positive, so we have 3 positive. Okay, based on this, we can perform the calculation. Oh, how do we get this value? Okay, very interesting. So let us try to actually perform the calculation. Okay. So now let's see. I'll be using R. Okay. So how do we calculate this entropy? Okay. If you remember the formula, right? There is a negative sign in front. Then it's probability of what? The probability of getting 3 positive. Okay, it has to be multiplied with log of 3/7. Okay, then plus 4/7 multiplied with log of 4/7. Okay, is this the answer? No. The key thing is in the formula, is log to the base of 2. Okay, in R, log is log to the base of E, which stands for natural number. Okay, so we need to divide it by 2. Oh, sorry about keying the wrong thing. Okay, but anyway, I think all of you can see the answer matches, right? Okay, for calculation, this type of calculation, 4 digit is sufficient. Okay, so okay, I hope you are able to calculate the rest. Okay, so turn it off and continue. So for humidity normal, right? Okay, we have 6 yes and 1 no. Okay, that's why it split into this. Okay, so for the split based on the normal, right? Okay, we can calculate the entropy to be 0.5917. Okay, why is it a lower value? Because you can see this is purer than this one, because nearly everything is yes, right, except for one. Okay, here is nearly half is yes, half is no. Okay, so how do we find the information gain? The information gain for this type of split is calculated this way. So first you need the original entropy before the split. So where can you get this? It's already given in your lecture notes. Okay, so overall entropy before splitting. Okay, the entropy of play, right? So how many yes we have? You can count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 yes, so that's why it's 9 over there are 14 rows, right? 9 over 14 log 2, 9 over 14, and then there are 5 no, right? 5 over 14 and 5 over 14. So this is the overall entropy before the splitting. That is why you actually see a 0.9403 there. It's related to this thing here. Okay, and what do we subtract to? We subtract it with just to increase the. Okay, so we subtract it with the entropy of humidity high and entropy of humidity normal. Okay, multiply with what? Multiply the probability of seeing them, right? Okay, so for this formula here, okay, this part, so you can think of it as something like taking the expected value, okay, which you have seen in your plot instead. Okay, so this is the information, how we calculate the information gain, okay, for play splitting up based on humidity. Okay, of course you want to take a look at others as well, right? So if we were to split based on temperature, so again we'll do something similar. Take the table, just take out the temperature and take out the play. Okay, but this time we're to split more because of what? Okay, based on the definition of our information gain, okay, we basically split things based on category, right? Okay, so we have hot, we have mild, and we have cold. So we split them. Okay. And then for each split, we need to further split, right? Okay, so play under hot, we have 2 no's, 2 yes. So that's why entropy is 1. Okay, because there's no way for us to distinguish, right? 50-50 chance. Okay, oh, sorry. Okay. Okay, so for Mao, we have 4 yes, 2 no. Okay, and we again calculate the entropy and so on and so forth. Okay, and cold. Oh, there's one thing I probably need to mention here, so I need to start this again. Okay, we need to start the R again. Okay, so the entropy is 1, okay, minus, so it's 2 over 4 times log. Probably this is not an issue for you. Okay, so I'm just trying to key in the thing here, right? And then what I want you to observe is because this in this kind of case, when we have a fair split, okay, the thing inside here, okay, 2 over 4, they are going to be the same. So these two can be added together. So adding together, what do we have? We actually have just this thing, right? Okay, only one expression, and divide by what? Log 2. This is equivalent to, okay, just take a look at this thing. This thing is the same as, okay, in log, when we switch order, what do we get? We get a negative sign in front. Okay, so here we have a log 2. So based on all this cancellation, finally we have 1. Okay, probably this is not something very complicated. I think later on we'll see something more complicated. So just leave it like this. Just comment it out. I need it later. Okay, let's come back to here. So I think you'll find that the calculation is the same. This is before the split, and then you need to subtract out all the possibilities, all the entropies here. Okay, so 0.9183, 8.113, I mean 0.8113. Okay, with the probability of seeing them. Okay, after subtraction, you get a value. Okay, so now let us look at Outlook. In Outlook, there's again we take out the Outlook and reorganize it. Okay, and what we find very special is overcast. We have, oh yes, okay, this is the situation where we say it's pure. Okay, it's just like the example I gave you on the truth table. Okay, the truth table, that is a situation where the three are either to the left or to the right, that you get the same output. So it's considered pure. So the node is not necessary. Okay, so these two are not pure, right? Okay, so why is this thing special? Okay, when you calculate the entropy, you have to be very careful because it involves this thing. Okay, because overcast, when you calculate the entropy, you have something like this. Negative. There's no null, right? So it's 0 over 4 times log of 0 over 4. Okay, this is the problem. What is log 0? Log 0 is negative infinity, and this is 0. How should we resolve this issue? For entropy, whenever we have 0 multiplied with log 0, you always have to change it to 0. Okay? You always have to change it to 0. So maybe, yeah, okay. You can't actually key in, otherwise you will get numerical value, numerical error. Okay, and then so the other one is rather simple, right? Because it's 4 over 4 all yes, right? Okay, multiply with log of 4 over 4. But I think everyone knows that log of 1 is equals to 0. Therefore, for sure you know this must be 0. Okay, you can see I didn't do division by log of 2 because divide by log of 2 is still 0. Okay, so that is how we get a 0 here. Okay, the rest are the same and the whole calculation are the same. Okay, so I think I'll temporarily break here and then continue with more examples later.